All right, welcome back to our unit on chemistry and measurement. Today's topic is measurement, okay? So, day 2 of 4, your objectives are as follows. You don't have to write these down, okay? You will learn how to convert extremely large or small numbers into what's called scientific notation. You will learn the difference between the terms accuracy and precision. You'll be able to solve problems with significant figures, okay? All right, for your quick write here, okay? Remember, your quick write is just to get you thinking about the topic. There's no wrong answer here. So, in 1 to 2 sentences, answer one of the questions below. You don't have to write the questions, just answer them. What are some measurements you might take in a chemistry lab here? Why do you think it is important to make accurate and precise measurements? Finally, in your own words, try to define the term accurate. Okay, so go ahead and pause this if you need more time to write. I'm going to move on here. All right, scientific notation. To make large numbers seem small, scientists use something called scientific notation. Let's look at the speed of light. Light travels 9,500,000,000,000 kilometers in 1 year. That's a very long distance. Remember, kilometers are like miles. So, 9,500,000,000,000 written in scientific notation is 9.5 times 10 to the exponent of 15, or power of 15. How did I get that number? 9.5 times 10 to the 15. Scientific notation here. Well, what I did is I moved the decimal over 15 places between the 9 and the 5. Let me show you. So here's our number, the speed of light. Okay, the speed of light travels in a year here. I moved the decimal over 15 places to the left. Okay, put my decimal in there. And I said 9.5 times 10 to the 15th. Okay, so that's scientific notation. You have about 50 trillion cells in your body. Okay, well, let's write this in scientific notation. Move the decimal over, okay, to the left. Throw our decimal in 16 places, which gives us a power of 16 here. Okay, so 5.0 times 10 to the 16th. Okay, written in scientific notation. Okay, so which one would you rather write? This short notation or the number with all the zeros? Okay, so in science we use a lot of big numbers and small numbers. Scientific notation just helps us simplify those numbers. So scientific notation is a useful way to represent numbers that are very large or very small. Okay, all numbers are written in a form of exponents of 10, such as 9.5 times 10 to the exponent of 15, or in this case, the powers of 15. Okay, so for your notes, question on the left-hand side here, answer on the right-hand side. What is scientific notation is the question. The answer, everything below the question goes on the right-hand side of your notes. Okay, go ahead and pause this while you write. I'm going to move on. Okay, so practice. You should always do practice problems for your notes, okay? Whenever you see a practice, you should be writing this down, especially if you want to do well on the test, okay? So go ahead and write this down and try to write this number, this huge number, in scientific notation, okay? Go ahead and pause this while you try it. When you're ready to see the answer, hit play. Okay, so here's our number. Let's write it in scientific notation. Moving this number over, how many decimals here? Turns out I moved that decimal 23 times, 6.0 times 10 to the 23. Turns out we're going to be using this number later on in chemistry, and this number is known to chemists as the mole. All right, so hopefully you got that right, or at least hopefully you were close. All right, here we go. Accuracy and precision. What's the difference here? So it is important to make measurements that are both accurate as well as precise. Accuracy is how close a measurement is to the correct or accepted value. Precision, on the other hand, is how close a measurement agrees with other measurements of similar value. Okay, let's apply these terms to our dartboard here. And our bullseye is our accepted or correct value. Then we can begin to understand the difference between accuracy and precision. Okay, so let's throw some darts. Okay, unfortunately, these darts were not precise or accurate. In other words, okay, they were not close to our accepted or correct value, the bullseye, and they were not close to each other in terms of their score or value. Okay, they were all far apart. So let's try again. Throwing some more darts, now we can see that these darts are precise but not accurate. In other words, okay, they agree with each other. The measurements are similar in their score or value, but they're not very accurate because they weren't close to our accepted value, which is the bullseye, right? Okay, so let's throw some more. And here you can see our darts are both precise and accurate. You can see that they're right here, okay, on our accepted value, so they're accurate, okay, and they all agree with each other in terms of their score or value, okay? So they're both precise and accurate. So what is the difference between accuracy and precision? For your notes, the question here will go on the left-hand side, and the answer, okay, will go on the right-hand side. As you write this, okay, go ahead and pause this as you write this. I'm going to move on. All right, significant figures. All right, so whenever you make a measurement, okay, with a device such as a ruler or a graduated cylinder, a certain degree of estimate is required, or at least should be required. For example, for whatever reason, let's say you want to measure the length of this nail. We can see that the length of the nail is between 1.5 and 1.6 centimeters. Okay? But no scale exists between 1.5 and 1.6. We must estimate the nail's length, okay, if we want to be, okay, more accurate. So, using a visual estimate, we could estimate the nail's length as either say, maybe it's 1.54, or maybe it's even 1.56, okay? So which one is it? 1.54 or 1.56? It is important to realize that the first two numbers are the same and are certain. They're certain because the ruler tells us so. Okay. However, the third estimate, okay, in the hundreds place here, can vary and is therefore uncertain. Okay, because we had to make an estimate. So we have certain values. We know they're certain because our ruler tells us so, but these are uncertain because we are guessing here, or we're estimating. Measurement, okay, when you're making a measurement, you should always have some level of uncertainty. So, significant figures are numbers recorded in a measurement that include all certain numbers, okay, plus the first uncertain number. So just like here, we have all of our certain numbers, plus we have one uncertain measurement here, okay, and those are significant figures. So, for your notes, what are significant figures? Question goes on the left-hand side. The answer goes on the right-hand side. Go ahead and pause this while you write. I'm going to move on. Okay, so significant figure rules. Chemistry requires many types of calculations and measurements. To help us obtain accurate and precise results, we must use a set of rules known as the significant figure rules. These rules are as follows. Okay, look at this number down below here. The first rule, all non-zero numbers, okay, are significant. So all non-zero integers or numbers count as significant. So anything that's not a zero, we say is significant. Okay? For example, in this number below, we have 7, 5, and 8. Those are significant. Another rule. Zeros in front of non-zero numbers or integers are not significant. So these 3 zeros are not significant. However, zeros between non-zero integers, okay, this 0 between the 5 and the 7, which are non-zero integers, are significant. So in the number below, this includes the 0 between 7 and 5. Okay, this is significant. Trailing zeros at the end of a number are only significant if the number contains a decimal. So, for example, in the number below, this includes the 0 at the end here after 8 because there is a decimal present. So let's review here this number. How many significant figures are there total? Well, we've determined that these 3 are not significant because these are zeros placed in front of non-zero, okay, integers or numbers that aren't 0. Okay, so we have 3 zeros not significant. Finally, non-zero integers are significant. In other words, numbers that aren't 0. So we have 1, 2, 3 numbers here that are significant. And then we found out that, okay, the 0 between non-zero integers is significant. So here we have 1, 2, 3, 4 significant figures. And finally, we learned that zeros, okay, at the end of numbers are significant if there's a decimal point, which makes this 0 significant. So a total of 1, 2, 3, 4, 5 significant figures total. Okay? So for your notes, practice here. On your notes, write down, okay, determine the number of significant figures in each measurement below. A piece of magnesium metal weighs 0.0340 grams. Okay? How many significant figures are in that? A piece of hair from a crime lab weighs 0.0050060 grams. How many significant figures are in this? Go ahead and pause this while you write. When you're ready to see the answers, hit play. Okay, so in this number we have 3 significant figures. 1, 2, and because there's a decimal, the 0 after 3 and 4 is significant. So 1, 2, and 3. Remember, zeros in front of non-zero integers are non-significant. Second one, in this number, we have 5 significant figures. Okay, these 3 zeros are non-significant because they're in front of non-zero integers. Okay, then we have 3 here, non-zero integers, 2, 1, 2 non-zero integers, and these 2 zeros are significant because they're between non-zero integers. And then finally, this 0 at the end is significant because there's a decimal point in the numbers, which gives us 1, 2, 3, 4, 5 significant figures. All right, rules for rounding off. Hopefully you've learned this before, okay, but we're going to review it, okay, because sometimes our calculators give us very large answers, okay, with a lot of digits here. Therefore, it is important we learn how to round off, unless you want to write this whole thing out, right? So let's round off. Consider the number below. It's made up of certain places. Okay, we have the thousands place. The 4, we have the hundreds place. The 5, we have the tens place. In the 6, we have the tenths place. The 5, we have the hundredths place. Okay, and in the 3, we have what's known as the thousandths place with a th on the end. Okay, so let's say we want to round the number below to the nearest hundredths place. Because the last digit 3 here is less than 5, our answer would be 845.65. Okay, so the 5 doesn't change because 3 here on the end is less than 5. Now let's say we want to round the number below to the nearest tens place. Remember, any number greater than or equal to 5, we round up. Okay, so this 5, because it's equal to 5, would make this 6 become 7, and our answer is 845.7. Okay? It is important to realize that when you are performing calculations on a calculator, only round off until you've arrived, okay, at your final answer on your calculator. Okay, so only round off until you get your answer. So practice, okay? Round each number to the nearest tens place, okay? A piece of magnesium metal weighs 1.58 grams. Round that to the tens place. A sample of water has a mass of 150.11 grams. And once again, round that to the tens place. Okay, do this on your notes. When you're ready to see the answers, okay, go ahead and hit pause while you work on this. And when you're ready to see the answers, hit play. Okay, so because 8 is greater than or equal to 5, okay, 8 here is greater than 5, okay, the answer is 1.6 grams. So if we round this up to the tens place, we get 1.6. Because 1 is less than 5, okay, right here, okay, rounding it to the tens place, we just get 150.1. The 1 doesn't change here, okay? So hopefully that was review for most of you. All right, so significant figure rules and calculations. You'll often be performing calculations that involve multiplication, division, addition, and good old subtraction. When using significant figures in calculations, there are rules we must consider. These rules are as follows. So, for multiplication and division, the number of significant figures in your answer will be the same as the number with the smallest number of significant figures. Okay, so read that again. For multiplication and division, the number of significant figures in your answer will be the same as the number with the smallest number of significant figures. So for example, let's say you perform the following calculation below. You type this into your calculator, 4.56 times 1.4, and here's your answer. Well, you don't want to write all that out. So the smallest number, 1.4 here, notice, contains 2 significant figures. So our answer must contain 2 significant figures. In this case, 6.3, or is it 6.4? Well, if we round correctly, our answer will be 6.4. Okay? Notice it has 2 significant figures as 1.4. Okay? All right, so let's move on to addition and subtraction. For addition and subtraction, the number of significant figures in your answer will be the same as the number with the smallest number of decimal places. Okay, read that again. For addition and subtraction, the number of significant figures in your answer will be the same as the number with the smallest number of decimal places. So, for example, let's say you type the following calculation into your calculator. Okay, 12.08 plus 6.2 equals 18.28. Well, which one of these, okay, has a smallest number of decimal places? We've got 1 decimal place here, 2 decimal places here. Well, here we have 1 decimal place. So our answer must only have 1 decimal place here. So the number with the smallest number of decimal places is 6.2. Therefore, our answer must contain only 1 decimal place. Okay, so therefore our answer will be 18.3. Notice 1 decimal place, 6.2 has only 1 decimal place. Okay, so for your notes, what are the significant figure rules? Question on the left-hand side, answer on the right-hand side. Okay, make sure you write these down because you'll be using these rules on your assignment later. Okay, so go ahead and pause this as you write. I'm going to move on. Okay, so practice here. Okay, solve each problem below. Make sure your answer contains the correct number of significant figures. Remember to round, okay, at the end. All right, as you work through these, okay, go ahead and pause this as you work through these. When you're ready to see the answers, hit play. Okay, so 5.8, you type that in your calculator, times 2.23 times 1.1. Well, the answer is 12 because 1.1 has 2 significant figures. Okay, these other two have 3 significant figures. So our answer must have only 2 significant figures, 12 in this case. Okay? All right. Next one, notice it's addition and subtraction. Our answer here is 2.7. Okay, why? Well, because 4.6 has only 1 decimal place, therefore our answer must contain only 1 decimal place. Don't forget to round when you're done. Okay? So 2.7. Last one's a little tricky. You got to use your order of operations, right? Multiplication, and we'll do what's in parentheses first, or multiplication and division first. Okay, so our answer, hopefully you got, was 12.1. Okay, this one's tricky, so listen. Because 1.33 times 2.8 equals, you should have gotten this in your calculator, 3.724. Well, using our significant figures, this one has 3, this one has 2, so our answer has to have 2, 3.7. Then you should have taken 3.7 and added it to 8.41, which gives you 12.11. Okay? Well, notice which one of these has the smallest number of decimal places? 3.7. So because 3.7 has only one decimal place, therefore our answer must contain only one decimal place. In this case, 12.1. Okay? That one's a little tricky. Okay? All right. So go ahead and summarize. You can always write your own, or you can complete the one I give you. Okay? In the expression you just did in that practice problem, describe how you were able to determine your answer using significant figures. Okay, imagine you're measuring an object with a ruler. Explain the difference between a certain and an uncertain measurement. How many significant figures does 0.8060 contain? How many significant figures does 22.1 contain? And then finally, summarize the significant figure rules if you can. Okay. Remember, your summary box has to be filled up to receive credit. Okay. Go ahead and pause this while you do your summary. Okay, and we'll see you next time for day 3.